path has become a circular path where body has to keep on changing its direction, and in that situation, to keep on changing the direction continuously, we need a continuous value of force. That means always a force is required. Now, so finally we have to define uniform circular motion. So uniform circular motion is already I have mentioned that when a body moves on a circular path with constant value of speed, constant magnitude of velocity, so in that situation body is said in uniform circular motion. So that is the definition. Now, overall this whole motion is considered a non-uniform motion. Why it is non-uniform motion? So for being in uniform motion, body can neither change its speed nor its direction. But here you can observe at all points body has to change the direction. So that's why it is a overall non-uniform motion. But then sometime it is asked, then why it is called uniform circular motion? Because it cannot be a uniform motion because its direction is continuously changing. But its magnitude is fixed. Magnitude of speed, velocity is fixed. The speed is constant. So at least one part of uniform motion is being followed during this motion. That is, there is a constant value of magnitude of velocity. One part of uniform motion is being followed, but another condition for uniform motion is not followed. But due to constant speed, we use the term uniform. But overall it is a non-uniform motion. So please take care of that. Now, since it is moving on a circular path and body has tendency to continuous changes direction of velocity, but at some point there must be some direction. Obviously next instant it has to change, but at that instant also some direction will be there. Then how do we decide that what will be the direction of velocity of any object at a particular instant on the circular path? That we are going to understand. Now, to get the direction of velocity of an object moving on a circular path, we use a word tangentially. Now, to understand this word, we have to understand some of the mathematical concept. So that first we should understand, and then it will be easy to understand how to decide the direction of the body which is moving on a circular path. Now, suppose it's a circle. One terminology we call tangent related to circle. Now what is tangent? Tangent is a line which touches any circle at one point. So suppose I have shown this line which is touching this whole circuit at point P at one point. Another tangent I have taken at point Q. So these lines which touches the circle at one point is known as tangent. Now what is the relation of this tangent to our topic? Now one of the property in the circle found that whenever we join the center to this point of contact where the tangent is touching, obviously it will become a radius. This radius is always at 90 degree to the tangent, or tangent is at 90 degree with radius. So that means between radius and tangent always a right angle is observed. That means they are perpendicular to each other. So now this concept is going to be applied to understand the direction for our direction for the object moving on a circular path. it is said that direction of velocity of an object moving on a circular path is always tangentially. That means whenever you observe the object on a circular path, suppose at point A we are observing, so it will have a tendency to move at 90 degree with the radius, whatever point it is, at 90 degree. Suppose the body has somewhere at point, has reached at point B. So here also it has a tendency to move at 90 degree to the radius. At C, again tendency to move tangentially to the radius. So how do we decide the direction of velocity on a circular path? Tangentially. And if you can recall that on any of the turn, if the force is not there, the body will not take a turn, then what will happen? The body will move with constant speed and with the same direction because the force is not there. So that means body has always a tendency to move straight. So it wants to move straight. It wants to move straight. But due to continuous force, body is not allowed to leave the circular path as long as the force is provided. Then what if a force vanishes? That also we'll understand. But right now we are discussing the direction of velocity. So how do we decide? We decide the direction of velocity at any instant wherever the body is on the circular path. It always has a tendency to move at 90 degree to the radius of the circular path. Okay. Now I want to show you one video in slow motion so that you can observe the body on a circular path, and then we'll discuss further different topics. Okay. So what have you observed while it was doing a circular motion? This metal, the metal was traveling on a circular path, and due to this thread, it is not allowed to leave the circular path because this thread is providing a force which keeps the object on a circular path, and this force is only known as centripetal force. So we'll discuss about that also. But right now, for direction of velocity, if you consider, so you will find out that at any instant, suppose this is the tangent with the, so, and this is the radius of the path. So it is always moving on a circular path, trying to move at 90 degree to the path. And what will happen, suppose the force is somewhere not present for a moment, vanishes. So what will happen to this metal? This will not follow a circular path. Then where will it go? Then it will have a tendency to move straight. Straight means at whatever direction it has a tangent. Suppose at this point it has this direction. So it will move somewhere here. Suppose it is in the path, is at here somewhere, and the tangent is somewhere here. So it will go this way. So the force keeps the object on a circular path, but the velocity always moves, the direction of velocity is always taken tangentially to the direction of radius. So suppose Earth moves around the sun, although it is an elliptical path, but for our approximation we take it as a circular path. There also the direction has to be changed, and there also the Earth has always a tendency to move tangentially. Suppose this is the sun, solar system, this is the Earth. So Earth keeps on revolving around the Sun. But Earth has also tendency to move tangentially. But due to some force, the Earth is not able to leave the orbit. But suppose this force is not present for any instant, what will happen? The Earth will start moving tangentially to the path, and in this way it will somewhere lost in the space. That means will not be able to exist. But due to some force, the Earth is moving on the circular path. And that means here also some force is needed, and that force is called centripetal force. Here what force is acting as a centripetal force? Here the gravitational force of the Sun is acting like a centripetal force. The force which is keeping the Earth on the circular path or in its orbit. Similarly, Moon is taking or doing orbit revolving around us. So there also some force is needed. And in Moon also it has always a tendency to move tangentially. And suppose any of that movement, Earth is not giving its gravitational force to the Moon, then what will happen to Moon? The Moon will also somewhere disappear in the universe. But it does not take place because our nature has made this kind of system that we have to move in our circular path due to existence of any force. So either Earth, Moon or any object which is moving on the circular path has a tendency to always move tangentially to the radius, but due to force it is not able to leave the circular path. If the force vanishes for a single moment, the body will start moving tangentially and on a straight path. On a straight path, because everybody has a tendency to move on a straight path, but due to force it is not done. So that is the direction of velocity. Now how do we measure the velocity, magnitude of velocity on the circular path? So since it is a situation in which the speed remains constant, so it means if one body is revolving around anything on a circular path, so this whole length will be taken as distance, that is perimeter. So I have taken perimeter as a distance and the time taken for one revolution or one complete revolution. So actually if you observe it, it is a situation of formula of uniform motion, that is distance by time. Because here the magnitude of velocity is not changing, so we can apply that also. But it is a circular path. It's not a uniform motion. But to calculate the magnitude of velocity, we can use the formula of uniform motion because the constant speed is there. Okay? So this is the formula for magnitude of velocity on a circular path. That is 2 pi r, that is the circumference upon time. So this is distance upon time. So this is the way by which we can get the velocity, magnitude of velocity. Now, we talked about a lot for centripetal force. Then we should have a better understanding of centripetal force also. One thing is clear, that this force is responsible for keeping any object on the circular path. In the absence of this force, the body cannot do a circular motion. So that is okay. So how do we define it? A force which keeps any object on a circular path is called centripetal force. But in its name itself, some more information is hidden. If we divide the whole word centripetal, centri means center and petal means seeking, towards. Means this force obviously keeps any object on the circular path and its direction is always towards the center of the earth, anywhere, like body has reached here. So its tendency will be force will be somewhere directed towards center. That's why it is called centripetal force. And it is very much required to keep any object on the circular path. So what is the definition of centripetal force? A force which keeps any object on a circular path and it is always directed towards center. So what is the direction of centripetal force taken? Towards center of the circular path. Okay, velocity is tangentially and force is towards center. And somewhere somebody asks what is the direction of acceleration, then direction of acceleration is also taken towards center. Okay. Now magnitude of centripetal force, that how much centripetal force is being applied in any of the situation. So this force has this formula, F is equal to mv square by r, where here F is the value of centripetal force and m is the mass of the moving object. Like Earth is moving on this orbit, so what is the mass of the Earth? V is what is the magnitude of velocity by which it is moving around the center, and r is the distance between that is radius of the circular path. So these are the factors on which value of centripetal force is dependent. Now here you can see force and mass both are friends, means we should understand this formula. Mass and force are directly related, that means they are friends. Means if more mass has to take a move on a circular path, then it requires more amount of centripetal force. That's why when we take turnings on somewhere road, for some instant on this turn you come on actually a circular path. So suppose this is circular path, this is the center. So suppose at the same distance a truck is turning, and at the same distance and same position suppose a bicycle rider is turning. Both have to move, so it requires a centripetal force, and here in this situation friction between the tire and the road acts as a centripetal force. Now if you are turning and your mass is more, then you require more centripetal force. In that situation, suppose the friction is offering some value of centripetal force, but you are demanding more due to more mass, then what will happen? Then you will not be able to move on the turnings, and then finally what will happen? Just like tangentially. So suppose truck is taking a turn, and due to its heavy mass it requires a large value of centripetal force, but the value of friction offered by the road is not large enough to fulfill the demand. Then what will happen? It happens whenever we take a very sharp turns, then it becomes very difficult. So it's a common experience. So when a truck take turns, especially on the mountain region and all, the truck has to take care of that it should not demand too much of centripetal force. If it is not available, then what will happen? It will not be on the circular track, and then it will fall on in the valleys, or it can be collide tangentially to any of the object. So when we are talking about magnitude of centripetal force, mass has to be taken care, and more mass object has to be provided more value of centripetal force. If it is not provided, then it will no longer move on a circular track. Then velocity also. It's a very common observation. When you take a turn, what do? You decrease the value of your speed. Why it is so? Because if you take a turn with a very high speed, then obviously the demand of centripetal force will be very high. Again, if you are moving on a circular track and demanding very high amount of centripetal force due to your very high speed, but the road is not offering such large amount of frictional force, then again what will happen? You will meet an accident. So you have to take care of that also. Then radius. They are enemies of each other. Means if you have a very less radius of your road, means you are taking very sharp turn. So when you are taking very sharp turn, suppose bicycle is somewhere here and truck is somewhere here, or one more bicycle is there. So for this bicycle and this bicycle, whichever is closer has to get more amount of centripetal force. That's why when we take a turn, we should not take a very sharp turn. There is always chance of accident. But when we take a large distance, that means when we are moving with a large radius, the value of centripetal force needed is very less, and that we get from the road condition, friction from the road, and we are safely able to take a turn. So force, centripetal force depends on three factors: mass of the object, velocity of the moving object, and the radius. So it depends that how, and on the road situation, if you are moving alone, if mass is not in your hand, mass will remain constant. So basically V, that means the velocity by which you are taking the turn, magnitude of velocity, and the radius, that you have to take care. Velocity should not be very high, and the radius from the center of your hypothetical circular path should be more and more. Otherwise, there is a chance of getting accident. You could have observed also when in a Formula 1 races, bikes or cars sometimes they meet with accident, because if they are not able to match with the road conditions, the value of centripetal force, they will skid and move tangentially to the path, and then they get a severe accident also. So that we have to take care. So how do we measure the magnitude of this centripetal force? F is equal to mv square by r. Now some application. To get some application in this situation, centripetal force is provided by this thread. Then how thread can apply any force? You will come to know the tension of this thread. It's a tight tension. This is providing centripetal force to this metal to move on a circular path. Similarly, here also, whenever you take a turn, friction is acting as a centripetal force here. In the case of Earth and Sun, gravitational pull of the Sun is acting as a centripetal force. In case of Moon and Earth, Earth's gravitational pull or force is acting as a centripetal force. In an atom, electrons revolves around the nucleus, their electrostatic force is acting as a centripetal force. Sometimes, if you could observe, hammer throw athlete are there, which has a hammer in their hand, and what do? They move in a ring in such a way that they, with their muscular force, they provide this hammer a centripetal force. And one thing they keep in their mind while releasing this, as soon as the athlete will leave the hammer, now it will no longer move on a circular path. It will move tangentially. So whenever in the competition, suppose this is the ring and this is the court area. So the athlete does practice in such a way that whenever it releases, that hammer should fall somewhere here. If somebody, suppose the athlete is the hammer thrower is releasing this discus somewhere here, or sorry, hammer somewhere here, it will be thrown somewhere here tangentially, and it will be a foul game. Then what does he do? He does practice in such a way that it always releases in such a way that hammer falls in between these boundary lines. Otherwise it will be a foul. So while doing the moving during inside the ring, the athlete is giving a centripetal force with a muscular force. So there are various examples where we can see the presence of centripetal force and which keeps the object on the circular path. Okay. So thank you very much.